What's up, ladies and gentlemen? I'm so excited for this moment. I'm glad that we're going to be solving now 6Q question. We've been working on the easy question, but I think this one is a little bit harder, and I'm glad that you guys will be learning different things with me. So let's improve our problem solving skills together. Today the question we'll be solving is really interesting and we'll be learning a lot, right? All right, so the question is called bouncing balls. We can go and read it together. So yeah, so I will kind of read it slow so that you can understand what it means, and we can maybe solve it together. We might have other ideas of how to approach it. That's why I always ask you guys, if you feel like interested or have an improved way of solving this question, why not in the comments? Yeah, you just write it in a comment and we learn from you as well. All right, so let's read it. So we have a chart. Is a playing with a ball on the nth floor of the tall building. The height of the floor above ground level, h, is known, right? So that means the height where the child is standing is called h, and it's given. He drops the ball out of the window, so he just drops the ball, and the ball bounces to 2/3 of its height, right? So every bounce is just bouncing 2/3. That means he kind of minimizing by 0.66, right? Every bounce. Then his mother look out of the window at 1.5 meters from the ground. So mother is standing at 1.5, right? That is the height where she's standing. How many times will the mother see the ball pass in front of her window, including when it's falling and bouncing? So that means we're gonna refer to the mother seeing the ball bouncing. So how many times, right? So we will count not the bounce, but we count the fall and the upward, right? So that those are what we'll be counting. So there are 3 conditions to consider, must be met for valid experiment. Float parameter h is a meter must be greater than 0. That's one thing to consider. So, and then float parameter bounce must be greater than 0 and less than 1. So the bounce must be between 0 and 1, right? It's a decimal, right? Then the float parameter window must be less than h for the experiment to succeed. So if all the 3 conditions above are fulfilled, return a positive integer. Otherwise, you return minus 1. So once they are like these 3 are correct, then you can return a positive. What else will return minus 1? So the ball can only be seen if the height of the rebounding ball is strictly greater than the window parameter. Okay, so the ball, you can see the ball. Like that means what they're trying to say, mother won't see the ball if the ball is bouncing below where she's standing. Maybe I can demonstrate that. Yeah, so let's suppose this is the ground level, right? And you have the height. This is where the child is, right? Let me call it this is height h. Okay, then we have mother is standing somewhere here at 1.5. Okay, then so once the kid which is standing up here, okay, throw the ball, then it will bounce, but it will bounce and get minimized at 0.6. Like 0.6 will be the 2/3 of the h. That's what they said in the question. That means for the first bounce, it will come, just fall on the ground, come back, maybe get here, right? Second, fall down, come back, get here. Third, down, come back, get here, right? But they said mother, the question is asking how many bounce will mother see? That means mother can only see the bounce from here, right? Where she's standing, right? The bounce which are here, down here, this one, mother will not be seeing them, right? So we won't really consider the bounce here, okay, at the top of the window where mother is standing. So so I think that's make like that the logic around, I think, is that h will be minimized at a time, right? So because for the first time h will be maximum, here they provide an example. H is 3, bounce is 0.26, window is at 1.5, which was provided, and result is 3. So that's what I was trying to mean. I assumed here. So if h initially was 3, at this bounce, the first bounce, the h has been reduced here, the front bounce, the h has been reduced here, then here, then here, you know, when a ball is bouncing till it just stay on the ground. So the only thing we're dealing with is to figure out here at this side how many times will it fall. Remember, we just consider the 4 and the upward, right? So those are what we'll be counting for the mother who is standing on this window to see. Okay, so yeah, so we can go and pass through the question. Now what we can do is to write the step through the question. So the first thing is to consider is to know that we have the parameters already given, the height, the bounce, and the window. So they say bounce should always be, okay, maybe I can use sample down. Bounce should always be greater than 0 and should always be less than, bounce less than what? Less than 1, right? This is first thing to consider. So that means it should be between 0 and 1. The second thing is we need to counter. We need a counter that will count the bounce, and the counter will be counting up and down, right? The third is that we have a condition that say that the window must be less than h. So we need something, the logic to approach this question. I haven't tried with recursion, but here maybe I think while is a good approach. So we consider also a condition that we run. This will be happening only if the h is greater than window, because mother will only be able to see the bounce that is greater than, that it have risen up to her. This is where I'm talking about. That means where we are in red, here mother won't see this bounce, but here on the in the green, mother will be seeing the bounce that will be happening. So what it will be the logic, that means we'll be just incrementing the counter. While this happening, counter will be incremented. How will it be incremented? I will just increment it by 2. Okay, why? Because we are considering the upper and the down bouncing, right? Then that's it. I think let's just go through the code and see that, right? Enough talking, right? So yeah, so the first step I would just follow this, right, is to consider that bounce is always between 0 and 1. So we write an if condition. Let's say if bounce is less than 0 or bounce is greater or equal to 1, that means we return what? We return minus 1, because the condition would not be fulfilled, right? Then the second approach, we have our counter variable, let counter, which will be initially equal to 0. Then we have a while loop, and the while loop, we say the condition for a mother. Now I'm taking mother as a reference to see the bounce is only if h is greater than what? Is greater than the window. Okay, so what will happen once the bounce, okay, I think this one has used them up, I can delete them. Okay, I think this is the only one we've used so far. Okay, so you guys can see, that's why I'm making that. So here, what will happen in the while loop, h will be changing time to time. It will be decreasing. So for the first bounce, h will be equal to what? It will be equal to h itself times the word times the bounce, which is the decimal. That means it's be reduced by 0.66. Okay, like they said in the question. Okay, so that means right here, okay, right here for the first bounce it's 3 initially, but if we bounce for the first time, we reduce with 0.66, we stay with something like 2 point something small, right? So yeah, I can make this bigger for you guys to see. Okay, so now we do have h which is getting minimized. So then for the, we say that each bounce there is a movement of up and down. That means our counter will be incremented twice, right? Okay, then okay, here it's JavaScript. Here I can even not repeat myself. This is a very good approach of writing JS. Then we will just refactor later. So then what we will return, the counter. Okay, so yeah, then maybe let's see if this is it. All right, we can test it. Let's run it. So here, let me minimize a bit. If I run the test here to see if what I did is correct, I know the result would fail, right? The reason why it will fail, here you see it expected 4 to equal to 3. What does it mean? It means I'm returning 4 while the answer is 3. Expected 16 to equal to 15. So that means I'm having 1 plus to the answer, right? So there's something wrong. And the reason I did it was that we have to also consider what happened if it's now bouncing at the last time. Let's say for the final bounce, it just came and get here, right? Now, if it minimizes 0.66, then it will, then it falls, right? So if it falls here and come back, it will just get somewhere here, okay? It will just be pretty late, right? So that's why here mother will only be able to see it coming up, but will not be will be able to see coming down, but will not be able to see coming up. So for the last bounce, we won't increment 2 times, right? For the last bounce, we just see it going down but not coming back, so we just subtract 1 here. I hope it does make sense. So if we test this one, yeah, it passed, so we can attempt. Great. So you see, now we managed to solve our question. So we can just refactor it. That's how this platform awesome is. But there's not much things you can refactor. Just delete the comment. You just maybe change the way we wrote this h. We can improve it. But yeah, you guys can try it out in your approach, and I know you can do more better than this maybe. So let's just submit and see what others did. Remember, if you submit, you can even learn from others. You see my marks now increase somehow bigger. So you see how others did it. They have the condition, they have while loop, so we are closer to how they did it as well. So yeah, thank you so much guys. I invite you to come on my channel. Just subscribe, write comments, have suggestion, and if you have other way we can learn in kind of improved way, I would like to hear your opinion, and I appreciate. So you guys, hope you subscribe. I will see you next time. Bye bye.